So today's lessons 6-8, graphing radical functions. Our objective today is to graph the square root and other radical functions. So we started off with, in the beginning of the chapter, with some really complex factoring where we had to do quartic roots and quintic roots and a lot of multi-step equations, and now we're down to the end where it's like we're going to graph something and we're going to move it around horizontally and vertically, and it ends up actually with a quite easy lesson. So I think you'll enjoy this lesson and the way we end the chapter here. The key concepts for this lesson is the square root and just a radical. And actually the square root falls into the radical, because the radical, we just have an index of n. Well, n could be 2, right? So if your index is 2, you just end up with a square root, right? So they are very similar, except with the square root, you're just not writing a 2 or any type of index on top of your radical right there. Now let's take a look at these. Remember when we had y equals x squared, and we said, oh, that makes a parabola. And then we can alter this equation to give it a horizontal and vertical movement. We can stretch it or compress it with an a value, and we can flip it over the x-axis or the y-axis by putting negative signs in certain places, right? We're going to do the same thing, except this one's just a lot easier. So let's look at the parent function, y equals the square root of x. And we're going to learn what that looks like in just a minute. Okay? And for any other radical other than square, it's just the same thing, except you're going to have a number right there where the n is. So the cube root of x. And actually the only two we're going to work with in this assignment is the square root and the cube root. But just they're giving you the rule with n there, because it could be any root. So now, what if you want to reflect this over the x-axis? Well, all you do is put a negative sign out in front of your radical, and that will flip your graph over the x-axis. If you want to shrink it or stretch it, depending on if your a value is greater than 1 or between 0 and 1, you put the a in front of your radical. So whatever that is, if it's a 1/2 square root of x, then that's going to be a shrink by a factor of 1/2. If I do 5, y equals 5 times the square root of x, then I'm going to have a stretch factor of 5 to the square root of x. So all this should start coming back, like, oh, we've done this over and over. And we'll continue to do this with every chapter when we learn something new, when we learn about the function and what it looks like, then we learn to graph it, and then we learn how to translate it. So now we're at the end where we're translating. So you should become very familiar with these. Now we're going to do a translation. Horizontal is the h, I'm getting tongue-tied. Horizontal is h and vertical is your k. So look at the original formula. You have x minus h plus k. So if I have a horizontal movement of 3, my h is going to be equal to 3. So that gives me a y equals the square root of x minus 3. We'll just leave the k off for right now. So notice, if you've got a minus 3, well, the minus is part of the equation. So my h value is truly 3. A lot of students get confused about that. They'll see y equal the square root of x minus 3, and they'll think, oh, I'm moving to the left 3 units. And that's not true, because your equation is x minus h is 3. So the horizontal movement is actually a positive 3 going 3 to the right. Does everybody see that? Any questions? And in the same respect, what if we had y equals square root of x plus 3? Well, let's make that fit the equation. Y equals x square root of x minus. Well, what does h have to be to make that an x plus 3? A negative 3. So now my h is -3, and I'm shifting 3 units to the left. So it's always like, we used to just say do the opposite of what it looks like for the horizontal, and this is why, because the original equation formula has a negative sign in it. All right, so, and everything's the same for the radical, except you've got an n, some kind of root here, a 3, a 4, a 5. Later in this assignment, we're going to have a 3 there. So we're going to work with square roots and cubic roots. So let's look at our first equation here, our first problem. Translating a square root function vertically. So we're just going to deal with the vertical movement, up or down right now. And that's that k value. So it's outside of the radical sign. It says, what are the graphs of y equals the square root of x minus 2 and y equals the square root of x plus 1? So they're asking us for 2 graphs. Oh, I forgot to, no, we're good. All right, so to graph these, I'm first going to show you what the parent function of y equals the square root of x looks like. We have to know that, right? So if you were to plug in a bunch of numbers, 0, 1, 2, 3, 4, because it's square root of x, we have to have a positive value in there, right? So we could have the square root of 0. So if I input a 0, I get an output of a 0. So let's graph that. 0, 0 is right here at the end of origin. Now, what happens if I take the square root of, let's see, what could I do? I could put a 4 in there, right? So y equals square root of 4. So if I input a 4, it's going to be a 2, right? So input 4, output 2, there's that point right there. And I could do the square root of 9. So if x is 9, y is going to be 3. So I've got a 9 and a 3. So over 9, up 3. So that's a pretty good idea of how this is going to look. And remember, it's half a parabola. So it's got a curve to it. So there's my parent function, y equals square root of x. And that's how it's always going to look. Now take note of these, what I call anchor points here, that I like to remember, that helps me do my homework faster and solve these things quicker. You've got a 0, 0, a 4, 2, and a 9, 3. And those are the points I would plot when I'm doing this parent function of the square root of x. 0, 0, 4, 2, and 9, 3. All right, just square root of 4 and square root of 9. They're perfect numbers, right? Whole numbers, 2 and 3. That's why I picked those. Any questions so far? So now that we have the parent function, that's the one that I just graphed here in the middle. It was the black dashed line. Now let's apply the movement to it, and that's the plus k value. So my k is a -2. So it means we are moving vertically -2 units, which means shifting down 2 units. So we're going to take this parent function and shift it down 2 units. So all those anchor points that I did, let's just pick each one of those and shift it down 2. So I'll use pink now. So here's this point, and I'm going to go down 2. 1, 2, and plot my new origin there, or vertex, I should say. And now I'm going to go to my next point and down 2 and plot that point. And my other point down 2 and plot that point. And now I can draw it. And underneath it, I'm going to write my equation, y equals the square root of x minus 2. So there's no doubt that that's my parent function there, and this is my translation of y equals x, square root of x minus 2. Any questions on that? Okay, let's look at the second one. Y equals square root of x plus 1. So again, you're going to take that parent function, and we've got a vertical movement of positive 1, so it means we're moving all those points up 1. So let me use blue. So we're going to take from that point again, up 1, plot that point, up 1, plot that point, up 1, plot that point, and connect your dots. And there's your new translation. So the one in the middle is your parent function, and the other two are the translations. Are there any questions on that? Pretty easy, huh? So if you will look at your assignment 6-8 and work problems 1 and 3, I can give you 2 minutes for that. Please work quickly. Okay, is everybody good? Anybody need more time? Okay, just another minute here. All right, let's move on. So let's look at our next problem. It says translating a square root function horizontally. So now it says what are the graphs of y equals the square root of x plus 4 and y equals the square root of x minus 1? So now we've got two horizontal movements, and they are inside the radicand, or inside the radical sign. They're part of the radicand. So we know that this x plus 4, that our h is going to be negative 4. Right? And over here, we know our h is going to be 1. So let's graph these. So start off with your parent function again. And this is a little different because we're going horizontal and not vertical now. So we're still going to graph our parent function. It was 0, 0, 1, 1, and then it was 4, 2, and 9, 3, but we don't go that far. It would be off the charts over here. So here's our parent function. I'm doing in blue right there. And now we know we've got a horizontal movement of negative 4. So we're going to go back on each one of these points, back 4. So we're going to go back 1, 2, 3, 4. There's your first point. From the second one, 1, 2, 3, 4, right there. 1, 2, 3, 4, there. And then the 9 would have been off the charts. It would have come in about right there. So now we're going to connect those dots in a nice curve. And there's your translation. And same thing for the second one, x equal negative, or y equals the square root of x minus 1. So now we're going to have a horizontal movement of 1, positive 1. So we're going to shift to the right 1 unit. So from the parent function, we're going to shift right. So over 1, graph it. And from that next anchor point, over 1, graph it. The next point, over 1, graph it. And that one would be off the charts again. So we're going to connect everything and say there's our new y equals the square root of x minus 1. Any questions on that one? I'm going to give you about 30 seconds for the next one. I want you to work problem 2. So when it turns 18. Okay, if you're not finished, just pause and you can take it home and finish it, or if we finish early, you can do it. Okay. All right, let's move on. We're going to deal with the A value now. So let's look at what happens when we have our A value be a shrink or a stretch. And notice that on the A value, we're going to do a double whammy here. They've got negative 1/2, so they've got to flip over the x-axis and a shrink of 1/2. On top of that, they added a horizontal movement of 3 and a vertical movement of 1. So all of the movements, all of those things are included in this one problem. So this is a beautiful problem to work through and to study by, because it has all of those movements, all those translations in it. But there's a trick to this. You could do lots of T-charts and lots of calculations, but let's do it the easy way. We always start with the parent function. So start by graphing your parent function and getting those anchor points of the y equals square root of x. And when you do that, you've got that 0, 0, 1, 1, 4, 2, and 9, 3. Right? Now, if I was to make a T-chart on that, I'm going to leave the 0, 0 off, but you've got 1, 1, 4, 2, and 9, 3. Okay? So there's your x and y. Now, when we compress or shrink, our x values stay the same. it's our y values that change. So let's make another column right here and call this my y2. So let's apply both of these at the same time. Let's flip it and shrink it at the same time. So to your y value, all you have to do is multiply by the sign and your a value. So I'm going to multiply my y values by -1/2 and get our new y value. So let's go to our old y value 1 and multiply it by -1/2. So that's going to be a -1/2. Okay, so now let's plot our new point. 1, -1/2. Oops, I need to do that. So when we do, you've still got the origin the same. I'll do it here. So now we're going to go over 1, down 1/2. So I'm going to put a little X there. There's my new point for my shrink. Now let's go to my next anchor point, that for 2. Now my y value is 2, so I'm going to apply that -1/2 to my y value. So it's going to be 1/2 of 2 is 1, and negative. So -1 is my new value. So let's plot our new point for -1. So now over 4, down 1, and there it is. And let's do the last thing to our last value. So -1/2 of 3 is -1.5. So 1.5, -1.5. So let's plot 9, -1.5. So it's going to come down right there. And let's connect the dots here and draw that compression. Right, so there's the graph compressed. See how it shrunk by 1/2, okay, from the parent function, and it flipped over the axis. Now we're going to take each one of those anchor points that I put the little X on, and now we're going to apply our horizontal and vertical movements. So we've got horizontal movement of 3 and a vertical movement of 1. So over 3, up 1. So for each one of these points, I'm going to go over 3, and we're talking about the one that I did the stretch on. So over 3, up 1, and there's my first point right there. Okay, and now let's take the next point, and it's at 1/2, so I'm going to have to stay in the 1/2. So over 3, up 1, so it's going to put me at 1/2 up there. So we're right there. My next point, I'm going to go over 3 and up 1, and I'm there. And that's all I can do on this graph. So I'm going to start at that origin and go down. And there is my new graph. That's all of it put together on this little blue one right there in the center. Okay, so graph your parent, get your anchor points, apply your a and sign to your y value for your new y value, plot those points, and get your shrink or your stretch. That was my bottom line right there. Then apply your horizontal and vertical movements to all the anchor points on that, and graph your new line. That's all there is to it. Any questions? Okay, if you will take, let's give you 3 minutes and see how far you can get on 5 and 6. And I'm going to pause the video this time. I'll give you 3.5 minutes. Well, no, I better not, because I'm afraid we're going to run out of time. I'll do 3. All right, I'm going to pause the video now. Starting the recording back up. Okay, so let's move on. If you didn't finish, you can finish it at home. So, oops, I left that there from last hour. Okay, on the next problem set, we're going to work number 7 together. Okay, so look at your worksheet. If you don't have your worksheet, the problem 7 says Solve each square root equation by graphing. Well, we're just going to solve it by solving, okay? And then we're going to round the answer to the nearest hundredth. We're just going to get the answer by solving this, okay? And, you know, on a multiple choice test, it doesn't know if you graphed or you solved it. So you're experts now at solving, so let's do it the old school way. Okay, I'll give you a break here. So they give us for number 7, the square root of x plus 2 equals 7. So let's just solve for x, right? We're going to solve for that little beauty right there. So what's the first step? Square each side and get rid of that square root. So we're left with x plus 2 equal, and 7 squared is 49. Now, what's our next step? How do we solve for x in our next step? How am I going to isolate that x? Subtract 2 from each side. Very good. And then you get x equals 47. If I told you you're done, would you be happy? You're done. Dunsville. Voila. Okay, so you've got that one done. Now work number 8 just like that. And if you don't have it, let's see. Number 8 is the 4x square root of 4. Come on, brain and hands, work together. 4x plus 1 equal 5. That's number 8. The square root of 4x plus 1 equal 5. So work that quickly, and then we will move on. It says if you can't find a solution, state no solution, explain why, but both of these are solvable, and your test will be solvable. Okay? If you're not finished, you can finish that at home. Okay, here's the last thing we're going to do. Woohoo! We might have some time left over to finish this and turn it in. Okay, problem 5 says graphing a cube root function. So now we're going to move to the cube roots. Remember when I said it just says radicals, but the only radical I said we'd be working with other than square is cube root? Well, here it is. So you're going to apply all the things we learned today to that about the stretch, compression. You're going to do it the exact same way, except your parent function looks different. Right? So what does the parent function of a cube root look like? Well, if I took a big S, capital S, and I grab each end and I pull on it, that's what it looks like. So let's look. So the dotted line, the black dashed line in the middle here, well, on the right side it's in the middle, but that black dashed line is your parent function of y equals the cubed root of x. So let me try to highlight it, but the highlighter tries to make a straight line. So I have to really exaggerate it. Nope, made a straight line. Well, it's that guy right there. I'll just color it yellow. Okay, the dashed line there. And it goes like from here down and over. It crosses through the origin and takes a drastic curve up and a drastic curve down. Okay? So that's our parent function. Now let's think about what points we can use for our anchor points. Well, obviously, it goes through the origin, so we can use 0, 0. So there's our first x, y point. And now let's look. What's our next perfect? It goes through 1, 1. And it goes through negative 1, negative 1. So let's just say positive, negative 1, positive, negative 1. And then the next point that's perfect cube is going to be Well, it would be 2 times 2 times 2, right? Which is 8. So we don't have it on the chart here, but it would be off the chart there. Okay. So let's work with these points. And let's go with this. So it says, what is the graph of y equals 2 times the cube root of x plus 1 minus 4? So we know we're going to take that parent function and we're going to stretch it by a factor of 2. And after we do that, then we're going to do the horizontal and vertical movement of, it's going to go left 1 and down 4, because we've got h is negative 1 and our k is negative 4. So let's first just apply that compression. Stretch by a factor of 2. So let's get some more points here. So the first one, 0, 0, well, it's going to say 0, 0. And now we want to apply, let's make another y, we'll call that y2. So now if I input a 1 for y2, I'm going to do 1 times 2, which is 2. And then when we do it times the negative 1, we're going to get a negative 2. So it's going to be positive negative 2. So input a 1, positive negative 1, we get a positive negative 2. So let's graph those. So if I input a positive 1, I'm going to get a positive 2. So it's that point right there on the red line. And if I input a negative 1, I'm going to get a negative 2. We just multiplied the y value by 2. Right? And we know it's still going to pass through our origin, so that origin point counts. Now let's look at this point. Well, let's look at the 3. 3, we've got 3, 1.5 right here. Over 3, up 1.5 on this point right there. That's 3, 1.5. So if we take that positive negative 3 and we get positive negative 1.5. Well, if we take 1.5 times 2, that gives us a positive negative 3. So let's graph that. Positive 3 gives us positive 3. So there's there and there. And a negative 3 gives us a negative 3. So over here and down here. Okay? And you could go grab other points and do this, but that's enough for now. We can say, and I'm going to use a different color now. I'm going to use this dark color. It's going to create this red line here that I'm going to go over in dark purple. So there's our translation of the stretch by a factor of 2. Okay, now what we have to do is apply the horizontal and vertical movement to each one of those points we just graphed. So we're going to go over or to the left 1 and down 4. So take your origin to the left 1 and down 4. 1, 2, 3, 4. So here's my new origin. And you're going to do that to every one of these points. So I'd be careful about doing scribbles because you're going to be counting over. Let's just do this. There it is. Let's see, what was it? Over 1, down 2, 3, 4. Right here. This is my new origin. Right, so I went from to the left 1 and down 4. Now I'm going to go to, let's do the points on my positive side. So I'm going to do this one here. So I'm going to take it back 1 and down 4. 2, 3, 4. So I'm here. And the next point I picked, this one. So we're going to go back 1 and down 4. 1, 2, 3, 4. Right here. So there's that. Now let's do the ones on the left side. So for this one, whoops, I picked the wrong one. That's on the parent. Actually, let me delete this. For this one here, we're going to go back 1 and down 4. So it's right here. And the next one, we're going to go back 1 and down 4. And he's there. So now the final image of our translation, and we've just got a piece of it because we've got a small chunk of a graph that we're showing, is this bottom one right there. Okay? You're awful quiet. Any questions on that? No? So your last 3 problems that you'll work are 11, 12, and 13. Okay? So that's it. When you're through with that, you're through with the assignment. Then you'll turn it in. If you finish before the end of the hour, give it to me. If you want to wait till Monday, that's fine too. But I would like for you, regardless, to work at least half your study guide over the weekend. There's only 16 problems, so that's 8 problems. You can do that, okay? And then we'll do it in class. We'll work on it in class Monday, go over it Tuesday, and the test will be Wednesday. Okay?
All right.
Thank you. That concludes our lesson.